In calculus, solutions become increasingly complex. It's important to show your work step by step, and that's where the notation d dx comes into play. So I'm going to show you how to use it in the following problems, so pay particular attention to d dx. And let's go. First of all, let's talk about the difference between dy dx and d dx. dy dx is a thing. It is the derivative. But d dx followed by a function says find the derivative of that function that follows. For example, d dx of, now we see the function, x to the fourth minus 2x plus 1. Using the power rule, we get 4x to the third minus 2, which is the derivative, or dy dx. When our solutions become complex, we will want to use the d dx notation in the middle. So we have here a complex derivative to have to take. Notice that we do have to use the product rule, where we say the first times the derivative of the second plus the second times the derivative of the first. And this is our first opportunity to use the d dx notation, and then we just perform the derivative in the following step. Now let's be super careful because we do have to employ the chain rule. I'm boxing the outside function's derivative, but let's remember that we also have to take the derivative of x to the third plus 1. That's the inside derivative. So I'm showing that with the d dx notation on the inside function. Now over here on the right, we already took the derivative of 3x squared, and that's showing up at the end there. In the next step, we have the last derivative to have to take, the x to the third plus 1, and that shows up here in the box 3x squared. And I combine the 3 times 2x on the end to become the 6x. Now we look for anything that might be in common factors, and we do see that between 3x squared and 6x, we have a shared factor of 3x. So let's pull that out. So I'm showing that leading on the far left. Pull that out and then show a result in the parentheses on the right. 21x to the third, just check how in this part right here you do have a remaining x, and I combine that with my 21x squared to be 21x to the third. And over here, what we have is our 2 is from the 6, okay? So we've got all of this together, and we combine then. We do notice that we have an x to the third and an x to the third. So our final answer is shown here in its most simplified form. So I hope that you can see in this problem that d dx was handy because it was a very complex problem to have to take step by step, and showing your work then helps you stay organized. So I hope this helps, and stay tuned for more great math videos.